So today's goal will be understanding angles that are not as you think of them. Okay, because when I say the word angle in here, and you think back to geometry and you think of an angle, what do you think of? Like, what was an angle defined of as in geometry? Oh boy. Stumped you. Throwing out those hard questions. What was an angle defined as? You don't even have a thought on that, what it was? Could you draw, if I asked you to draw an angle, could you draw an angle? Come on. What was it, guys? What was it? Oh, space between where two lines intersect. Okay. I kind of understand what you're saying there. So you're kind of saying, it may not be two lines, it could be two rays with a common end point. Come on. Like, that's a ray, that's a ray. They have a common end point, right? And that region between them is an angle. We would call that an angle, right? And it's what? It's the amount of rotation to go from here to here, or from here to here, right? Now that's the idea. It's the amount of rotation between one ray to the next ray. Now, we know that this angle here is what type of an angle? Acute, right? Now, is this an angle is my question right now. And it is. But it's an angle that's greater than 180. Okay? It's just an angle still, though. An angle is still a rotation. What would be true about these two angles, by the way? This angle here, theta and beta. Theta adds to 360, right? Because there's how many degrees in a full rotation? 360 degrees, right? Okay, so today we're going to be talking about angles, and we're going to be talking about what you're familiar with, okay, the idea of degrees, and then we're going to go to the other type of angle measurement we're going to be dealing with in this class, and you're going to need to know, which is radians. So we're going to go ahead and do this. So everybody's going to get a packet here. Yep, you're welcome. I don't see much energy in here today. Is today harder than yesterday? Yes. I feel like for some people, this has been a harder, the people are struggling more today than they were yesterday because like, oh, I gotta do this. Oh. What's that? Why is that? Last period got you thinking? Well, that's a good thing. That's a really good thing. Okay, so in front of you, you see this, okay? So on here, there is some important vocabulary. I'm going to change masks if you don't mind. Some important vocabulary, and the real important things are kind of, some of those are at the top. And we'll kind of, you can go back as you want to and fill some of these things in, and we might fill some of them in at the very beginning. Okay. And I have misplaced something. I don't know where I placed. Put it over here. This chair over there. Okay, great. So, how many of these things up here do you already know? Like, if you're looking at these important vocab terms, trigonometry, central angle of the circle, complementary angles, supplementary angles, degree, and radian, how many of you know what all of those are? Kind of, maybe no. Okay. How many of you know, what do we got there? 6? How many of you know 5 of them? And when you say you know them, you know them. 4 of them? You think you know 4 of them? 3 of them. Probably, I would hope you'd know maybe at least 3 of these, for sure, okay? You should know at least 2 of them. And yeah, you better know 1. All right, great. Okay, so, I'm just kind of curious. If you know one of them, tell me what You had your hand up, Caitlin. What one did you know? What's one of them you know already? You know supplementary angles. Okay, good. Complementary angles. Those two are from geometry. Okay, who else said they knew three of them at least? Ryan, what was the one that you knew? Another one. Degree. Okay, good. So these three we're thinking we might know. Okay, what about these other ones? Trigonometry, central angle of a circle, or radian. Anybody know any of those? You might know that one, guys. Central angle of a circle. And it's last year again. Last year, I'm not sure what happened, where you guys got by the time you left. And I know once you guys left and there was no testing anymore, that everything was kind of like changed. So I understand that maybe you haven't heard that term central angle. Okay. All right. Well, we're going to go ahead and we'll come back and fill some of these out a little bit. So we're going to come down here and you'll see you've got this picture and you've got this. Now, looks like you're looking through maybe a scope or something like that. But what we have here is we have a circle and we actually have on this the X and Y axis and they're centered. So this is a circle that is centered at the origin, in other words. Okay? So this is the origin right here. Okay, so this is the positive x-axis, that's the negative x-axis, that's the positive y-axis, that's the negative y-axis. Okay? So that's what this is. And we don't have any marks in here at all. Okay, so here we go. First, what is an angle? What is it determined by? Okay? An angle is determined by rotating a ray about its endpoint. We kind of already discussed that. Now, really and truly, you start with one ray, and then you rotate it, and when it stops, that's kind of like your second ray. So it has a starting and a stopping spot, okay? And that's what these refer to as here. Okay, so in geometry, you didn't think about it actually being so much of one ray being rotated, but we are going to start thinking of it as a rotation of a single ray about its endpoint. Okay, so the initial side of an angle is, well, guess what? That's where the ray does what? Initial, what's the word initial or initiate mean? To start, to begin, right? So it's where the angle starts, right? So the initial side is the position it starts at. Oops, I can't do that anymore. Okay? So it's the position that the angle starts at, or the ray starts at, that is considered the initial side. So let's say I went ahead and I just drew a ray like this. This is going to be the initial side. I'm just going to call this the IS, the initial side. Okay? Easy enough. I could have put it anywhere I wanted. It didn't matter. I put the endpoint though where? At the origin. Okay, so I'm going to rotate around the origin is what I'm going to do. That's where I'm going to be putting my endpoint every single time. All right? All right. Terminal side of the angle. Feeling a little tired today. Okay, so the terminal side is, the location where it stops rotating. So here I have my ray, okay? And I'm just going to start rotating it. I could go, I'm going to go like a clock. I just put my finger on there. Boom, I'm going to go right here. Boom. This is where I stopped at. Okay? So I rotated like this and I stopped. This would be considered the terminal side. So we got the initial side and the terminal side. All right? That's just basic terminology we need to understand. If I say, where's the initial side? Where's the terminal side? That you understand what that means. Okay? The vertex of the angle, that's not as important. We should know what that is, though. The vertex of the angle is the what? What is the vertex, guys? Yeah. Yeah, it's the point where the terminal side and the initial side what? Meet. It's that common endpoint, okay? So the vertex of an angle is common endpoint of terminal, I'm going to put initial side, IS, and terminal side, okay? So again, that's just IS is initial side, TS is terminal side. That's what I'm using right now on this note sheet. Okay. So far, hopefully that doesn't sound too crazy to you, right? All we're talking about is in here, what is an angle? It's a ray being rotated. Where it starts at is initial side. Where it ends, stops rotating is called the terminal side. And this point right here is called the vertex. Like we do. And our vertex is going to be at the origin. Right? Now, here we go. Now we're going to get a little different. Now we're going to go beyond that. So the next part says an angle is in standard position. All right. What in the world does this mean? An angle is in standard position when the initial side is on the positive x-axis. The initial side is on the positive x-axis. Okay? So in other words, if I wanted to take this up here and I wanted to draw a new angle that's in standard position, I would need to have the initial side be on the positive x-axis. Boom. Here's my initial side. It's on the positive x-axis. Okay? So I'm going to go ahead and just draw an angle. Boom. Okay? So I could go ahead and draw this angle right here. Maybe I decided to rotate this direction like a clock, like the hands of a clock go like this. All right? So here, this angle right here would be in standard position. Beta is in standard position. And the reason I know that is that the initial side is on the positive x-axis. The terminal side could be anywhere else. It doesn't matter where it's at. But the initial side must be on the positive x-axis. Now, first question is this. When I draw this initial side here, if I would choose to not rotate that ray, what would the measure of its angle be? What if this was the initial side and the terminal side? I start there, and I pick up my finger and I said, I'm done. What kind of a rotation is that? It's a what? There's none. So what number is that? 0. So if I don't rotate at all, it's a 0, right? So when I start here, I'm starting at what degrees? 0 degrees. This right here where I'm starting at, this is at 0 degrees. The initial side, if we're in standard position, will be at 0 degrees. Notice, it's not up here at like 12 o'clock. We might think it should be at. It's right here on the positive x-axis. That's where 0 degrees is going to be located at. Okay? Now, why is that important? When we draw angles from standard position, we have a choice of which direction we choose to rotate. I can rotate this direction, or I can rotate this direction. Now, those have words that describe those rotations. If I go ahead and I rotate this direction, does anybody know what that direction is referred to as? Counterclockwise. So we're thinking about these clocks right here. So when you see the second hands, minute hands, the hour hands, they all rotate this direction. So the way that they rotate is called clockwise. And if you go the opposite of that, it's called counterclockwise. So this right here, going this direction, would be called counterclockwise. clockwise. And then going this direction will be called clockwise. Now, why does that matter? Well, here's why. Because one of those is considered a positive angle, and one of those is considered a negative angle. So now we're going to have positive angles and negative angles. You've never dealt with negative angles in the past. So the direction that I rotate is going to be either positive or negative. So how do we know what it is? Well, here we go. A positive angle is generated by a counterclockwise. Rotation. Okay? That is a counterclockwise rotation. Whereas a negative angle is generated by a clockwise rotation. Now, anybody have any ideas why that might be true? Why do you think that how do you think we have this being considered counterclockwise and the other one is clockwise? Anybody have any thoughts on why that might be true? You gotta see why that just did there. Why is that popping up? And you guys think about that for a second. I don't know why this wants to continue opening up on the screen. Just get rid of that. Any thoughts? Anybody? Anybody? Nobody has any thoughts as to why? Yeah.
Because
Whoa, what in the world is going on there? Okay. Yeah, go ahead.
when you start in standard position, if you go counterclockwise, you're going up on the y-axis, and when you go clockwise, you go down on the y-axis.
Okay. So, I kind of like what she's thinking. Remember what I told you about this circle? It's centered at the origin of the coordinate grid. What do we call this region right here? Quadrant 1. So when I rotate into quadrant 1, it would make sense that I'm going into the first quadrant. That should be a positive rotation. And when I go into quadrant 1, both x and y coordinates are what? Positive as well. So when we go into quadrant 1, that's going to be positive. As long as I keep going this direction, it's positive. So there's quadrant 1, 2, 3, and of course quadrant 4 as well. Okay? All right. So now we have to understand that we have both positive and negative angles. How do I know when I draw? Like when I have this purple angle here, how would somebody know? Like if I were, I'm going to just put a new page in here. You don't have to do this. If I went ahead, drew a circle, had the coordinate grid like this, and I just drew an angle like this all of a sudden. And if I said, hey, is that a positive or negative angle? How would you know from what I have there?
You have to know if it's counterclockwise.
Right. You have to show somehow on that picture, is it clockwise or counterclockwise? All right? Easiest way to do it is to put it between these two things. Now, if it's a standard position, this would be a positive. And if I went the other direction, if I drew it like this, then I'd be talking about the negative angle. So this is going to tell me which direction the rotation was going. That little arc on the inside with an arrow is telling me the direction it's going. Whether it was a positive rotation or a negative rotation. Okay. All right. Now we know, even though that this is a negative number, it's at the absolute value of these has to add up to 360. We kind of talked about that earlier. The absolute value of these has to add up to 360 degrees. All right. We're doing good. You guys are doing great. Here we go. Let's keep going down here. So, last one. Here we go. If two angles are coterminal, okay, so the prefix co. What would that be? Who knows what the prefix co means? with. Okay? You coexist, it's together, it's with something. Okay? So coterminal angles are angles, okay, that exist with the exact same initial and terminal sides. Coterminal angles have the same initial and terminal sides. Okay? Those are considered coterminal angles. So if I go back to that picture I just had, this angle and this angle are coterminal angles because they both start here and they both end here. Okay? So if I named them, if I called this one right here theta, and I called this black one over here beta, I could right down here, I could put down, oh, theta and beta are coterminal angles. All right? Okay, here we go. Here's my next question for you. Do you think that theta has any other coterminal angles up there on the board that maybe just aren't drawn yet? Are there any other coterminal angles to theta that I don't have drawn on the board already? What do you think? No idea? It's okay. All right, well, here we go. Yeah. Guess how many there are? Guess how many coterminal angles theta has? Theta has an infinite number of coterminal angles. It has an infinite number. Now, you might be saying, how's that possible, Mr. Snyder? Well, here we go. I'm going to draw a next one. Here we go. You ready? It's going to start right here, and it's going to end there. Does that meet the description of starting and stopping at the same spot? Yep, sure does. What about this one? Here we go. Does that start and stop at the exact same spot? Yes, it does. So the blue and the purple are both coterminal. All four of those angles are coterminal. What happens, in other words? To get a coterminal angle, all I have to do is go around another what? Full rotation. Every time you add a full rotation, guess what? You're going to get another coterminal angle. Every single time you get a coterminal angle, you're right back where you were before. You start and stop at the exact same spot. Okay, so that's why there's an infinite number, because I could go around an infinite number of times. Okay? Okay. So, before we go any further, is there anything on here, on this bottom part, that you want to ask about? Anything at all? No? We're okay so far? All right. What do we got here? Second, third, 10:21. Okay, so we're gonna move forward here. Hey, I'm kind of curious. I'm gonna put it real quick. Can anybody? Okay, here we go. Whoop, whoop. Can somebody estimate what they think that is in degrees? Estimate. What do you think, Riley? How many? 100 degrees. So why'd you say 100? It's a little bit over 90. Yeah, you hear that? This has to be at what? If I stopped here, I'd be at 90. Because that's 0. So this would be 90. What would this be if I stopped over here?
180.
If I go back around where I started at? 360. All right, great. So yeah, this can be about 100 degrees. I'm okay with that. if that is 100 degrees, what's this one equal then approximately? Careful. Negative 260. All right? Negative 260, because it rotated the opposite direction. Okay, so I know in geometry there were no negative angles. Now we have negative angles. Okay? Now we're going to have negative angles in here. Okay. Let's go back to this. Okay, here we go. So this top part right here, this should be pretty straightforward for you, hopefully. Degrees. Okay? So it says a full revolution counterclockwise, which means it's a what type of revolution? That would be a positive revolution, right? A full revolution counterclockwise around a circle corresponds to, we know what, 360 degrees, right? We all know that. And we all know the degree symbol is the little circle. Everybody knows that already, okay? And then a half revolution around a circle corresponds to 180. So those are things that should not be an issue for us in here. We should know a full rotation 360, a half rotation is 180 degrees. No problem, right? All right. Now, tell you what. Let's go back to the box at the top. I want to fill a few things in that we can right now. So I'm going to go back. So let's talk about central angle of a circle. Central angle of a circle is an angle whose vertex is at the center of a circle, right? So in other words, every one of these angles is a central angle because the vertex is at the center of the circle. So those are called central angles, okay? So again, a central angle of a circle is an angle with vertex at the center of the circle. Okay, and guess what else is true about it? The sides are what of the circle? What is this blue thing of this circle?
The radius.
They're a radius, right? Those are all radii, okay? So it's an angle with vertex at the center of the circle. Sides are radii. There we go. All right, good. Got that one done. You guys told me you already knew these two. You told me you knew what complementary angles were and supplementary angles were, okay? So let's see. Okay? So complementary angles. Who was it that said they knew what complementary? Was it you or supplementary? You complement? Okay, what was complementary, Riley? Great. Okay, so here we go. Two angles with sum of 90 degrees. Okay? Two angles with a sum of 90 degrees are considered complementary, and supplementary are? Perfect. And the supplementary is two angles with sum of 180 degrees. Now, in geometry, that is completely fine. There's nothing wrong with that. Okay? In here, this would be my next question, just because that's who I am. If I told you the following, and I asked you, are those complementary? Okay? Are those complementary? What do you think I'm going to say now? You think I'm going to say they are or they're not? What do you guys think? You think they're not? Who thinks they're not? Anybody think they are for sure? Okay, they're not. So they have to be positive angles. We're talking about a positive sum here, guys. Okay? Now, I'm not going to try to trick you with that kind of a question in the future. Don't worry. I just wanted to go ahead and ask that. Okay? So I'm going to get rid of that. We're done with that question. We're going to move on. degree. If you had to define what a degree is, what would you define that as? How do you, I mean, that's kind of a weird thing, right? How do you define it? What's that? It's a unit of measurement for a rotation, right? It's what it is, right? Degree is a unit of measurement used in rotations. Okay? All right. So the only two we haven't done right now are trigonometry and radian. Trigonometry and radian. All right. I think we are ready to kick on to that other page and take care of this whole idea of a radian. All right? Make sure I don't forget anything in here. All right. So, so radian, here we go. This is going to be the second way of measuring a rotation, an angle. It is the way that is more commonly used in higher level math. We use the idea of a radian, okay? So the measure of an angle is determined by, all righty, now I guess before I even put a word up here, I need to make sure you understand something. So just, you don't have to write this down. I want to see if this is something you did learn last year or not. So I'm going to use a word that I'm like, I'm not sure if you've even done this. Okay, here we go. Circle. No problem, right? Okay. If I take this circle and I only look at this piece of the circle here, what is that referred to as? What? It's an arc. How many of you guys have heard the term arc? Okay, great. Now, first of all, and this is stuff I've got to make sure you know before I move on. So here we go. If I measured the arc, I'm going to draw another arc up here. Here we go. I'm going to draw this arc. What is that arc referred to as? What? A big arc, yeah? It's a circle. Yeah, it's a circle, right? Okay, great. So, does this red arc have length? Is there length on an arc?
Yes.
What do we call this red arc length? Circumference, right? You guys knew that. It's a circumference, right? So the red one is the circumference. Okay, great. So my question now is, does this arc have length as well then? Yeah. Does anybody know how you find arc length? This is what I'm not sure if you guys did in geometry. Yeah. You have to do what? You have to have an angle, yep. Okay, so this is stuff that from geometry you may not have gotten. I just don't know. Here we go. You would have to know this central angle's measurement. You'd have to know it. Okay? So let's just call this central angle theta. Right? This arc is nothing more than a fraction of the circumference. How do I know what fraction of the circumference it is? It's the angle over 360. Okay? You did this? Remember this? So arc length is equal to theta over 360 times, I'm just going to put, what's the circumference? 2 pi r or pi d. Doesn't matter which one you think of it as, right? So that's arc length. That is arc length, right? Okay. No problem. You good with that? I almost feel like waiting until next period to begin this next part. Once we get into it, I don't want to stop. Just take a break here for a second. We're going to go ahead. When we come back, we're going to jump into this whole radian stuff. I want to be fluent and go straight through it. So we're going to do that. We're going to wait a second here. I'm going to
sip this coffee and might even open some windows so it feels good out there. I'm gonna actually open up some blinds too, I think. Oh, yeah. Well, sunlight feels good. Oh man, there's chat stuff going on. That's fine. Good. Take that break.
I can't play 8-ball on an Android.
Yeah, it's fine. I don't mind. That's fine. Oh, I got your book, by the way, earlier. Just so you know, I took care of it, marked it off.
This is howdy. Look, these kids never want to leave the room.
I know, they're just such sweet kids.
Either that or they're so tired they can't get out of their desks. I'm not sure which one it is.
Could be that.
Maybe it could be that.
You never know.
You get my lunch? You got my lunch? Yes, it is. That's my lunch. What's in my lunch bag? You don't know? Maybe I should check. Make sure I'm not allergic to anything.
Oh.
What do you think of that idea? Nothing. So maybe I should make sure that there's nothing in there. Nothing. Sure I don't have any germs on my hands.
Looking at that lunch bag. I am, I'm looking at it. All right, here we go, guys. So, oh, by the way, well, we don't need that. I can do it here. Okay, here we go. So, the measurement angle. So, we're going to talk about how do you find out what a measurement is in radians. Okay, what is this radian measurement all about? Because degrees, all they did was they took a circle and they broke it up into 360 equal spaces, and 1 degree is 1/360th of a full rotation. That's what it is. That's what a 1 degree is. It's 1/360th of a full rotation. Okay? What about this radian measure? How are we going to calculate a radian measure? Well, this is how it goes. All right. It's determined by, are you ready for this? Dividing arc length of rotation by radius. Okay? You take the arc length and you divide it by the radius. Okay? That's how we're going to go ahead and find out what radian measure is. So let's think about this then. That means if I were to just draw a little circle here, okay, like this, and I told you that this is R, that's the radius, and I drew an angle here in standard position. Let's say I did this one right here. This is theta, and I'm going to call this arc length here, I'm going to call this S, all right? That would mean that theta, if I write this down then, theta would be equal to S divided by R. That's if you want the measurement in what? Radians. That's if you want the measurement in radians. Okay? All right. So then we get down to this thing called 1 radian. 1 radian. Well, let's think about this. If theta is 1, if theta is 1, what does that tell you about S and R? If theta is 1 radian, what would be true about S and R? They have to be the exact same. That's what 1 radian is. 1 radian of essential angle theta that has an arc equal to its radius. Has an arc equal to its radius. When you have that happen, you are looking at an angle of 1 radian. You're looking at an angle of 1 radian. So 1 radian, okay, 1 radian equals S over R when S is equal to R. That's what happens. That's how you get 1 radian. Okay? So algebraically, this means that theta equals, we already put this down, I put it up here, theta is equal to S divided by R. It just goes here as well, right? Okay. So let's think about this now. Here I have concentric circles at the same center, all right? I'm going to tell you that this is at 1 and this is at 2. This is at -1, this is at -2, 1, 2, -1, -2. Okay, great. All right. So here's a question for you. If I draw an angle here in standard position, okay? I wish they had waited until the end of the year to give us new computers. We didn't have to deal with this changing stuff mid-year. All right, here we go. We've got 2 circles. I've got this arc length, I'm just going to call that S1, and I'm going to call this S2. Are those arc lengths the same? No. Are the arc lengths measurement or this angle's measurement going to be the same? In other words, if I look at this rotation on the small circle and this rotation on the large circle, is it the same? Yeah. Is the amount of rotation the same on both circles is the question. And the answer is yes. Now here's the thing. This central angle, the measure of this central angle and the measure of this arc in degrees or whatever unit you're using are always going to be the same. Okay? So these have different arc lengths, but they're going to have the same measurement in degrees and the same measurement in radians. All right? Okay, so let's write something down here. A central angle of one full revolution, okay, counterclockwise, corresponds to an arc length of S equals what? This is not a trick question. I did this last period. A central angle, here we go, guys. Here's my circle, here's my thing. A central angle of one full revolution counterclockwise. So that means I start here and I rotate and I come back like this. Here we go. Yeah, it's the what? Corresponds to the arc length of, but how do you find circumference? 2 pi r. 2 pi r. That makes sense, doesn't it? Instead of saying circumference, we're just calling it the what? Arc length of S. Okay, so then what does this mean? Well, look at this. The radian measure of an angle of one full revolution. Here we go, guys. Here's theta. We know theta is equal to S over R. Right? What is S on this red one? 2 pi r over R. What do the R's do? Cancel out. What does theta equal? All right, so here we go. This is huge. The radian measure of an angle of one full revolution is 2 pi radians. 2 pi radians is the same as 360 degrees, in other words. When we're talking about this measurement of radians, which is all about arc length compared to radius, 2 pi radians is a full rotation. And of course, that would be a, what kind? If it was positive 2 pi, that would be a counterclockwise. If I went clockwise, it wouldn't be positive 2 pi, it would be negative 2 pi. All right? A half revolution would correspond to an angle of how many radians then? Pi radians. Yeah, you just take it and cut it in two, right? Half of it. Half rotation will be half the circumference or half the radians. It'd just be just divided by 2, boom, pi. So wait a second here. I'm starting to see something in my head. Circle. We said when I start here, this is how many degrees? When I start here? 0. It's also 0 radians. 0 is 0 is 0 is 0. So when I start here, I'm at 0. We know if I go all the way around, I've gone how many radians? How many radians? 2 pi radians. We know if I go halfway around, I've gone pi radians. Right? Now it says, similarly, 1/4 of a revolution. 1/4 of a revolution would be, what's that going to be then? 1/2 pi, or just pi over 2. Okay? 1/6 of a revolution. 1/6 of a revolution. Let me get some purple here. Okay? So 1/6 of a revolution will be about, right about here maybe. That's 1/6 of a revolution. What would that be in radians then? Pi over 3. How did you get that?
Take 2 pi and put it over 6.
Yeah, you just put 2 pi over 6 and simplified it. I'm going to put 2 pi over 6, which is pi over 3. Okay. Wow. All right. So that's the first thing, is understanding angles in radians. So before we go down here, let's go back over to this page. You don't have this, I have it here. Okay, here we go. So I'm going to go ahead, and I'm just going to go ahead, and if I told you that this was a radius of 2, all right? And let's say I went ahead and went, oh, I don't know. I stopped here. Here's theta, okay? And let's say I told you that S was equal to, what do I want here? Oh, I need something nice here. I don't want to make it too nasty for you. Do I?
No.
No? Okay. How about we make it, I'm just trying to make sure I don't want to do anything silly here. How about 5 point, we'll just make it 5. How about if I told you this has an arc length of 5? Okay? How many radians is theta? We're going to make this easy on ourselves. Yeah, so theta would be 5/2 radians. Now notice, there is no pi in there, is there? There's no pi. In other words, when you're measuring something in radians, it will not always have pi in it. It won't. It's arc length divided by radius. Okay? That's what it is. So that would just be 5/2 radians. Okay? That would be 5/2 radians. What would this be then? What would beta? Now be careful. What would beta have to be? This is how would I find out what beta is? Well, I could find the other arc length, but what would those two angles have a sum of if I ignored positive and negatives? No degrees. We're not in degrees right now. What's the sum of these two angles going to be in radians? 2 pi. The sum of their absolute values would have to be 2 pi. So if I wanted to find beta, I could do what? Do 2 pi minus 5/2. I mean, that's what I would end up doing. That'd be the idea of it. But I'd have to make it a what kind of a number? A negative, because it's a rotation in a clockwise direction. So wait, if I want it to be a negative, couldn't I just do this then? Instead of saying I want it to be a negative of this, wouldn't that be the same as saying just take the original 5/2 and do what? Subtract 2 pi from it? Isn't this going to be this? Yeah. All I have to do is take this and subtract 2 pi to get the other one over here. That's it. Subtract it.
And then if I wanted to, I could combine it. But if I knew this, that's a good start for me right now. Understanding that. Okay. All right, let's go back here. Where we are. Angles with measures between 0 and pi over 2 radians. Between 0 and pi over 2 radians. Anything here are what types of angles? This is a word you know. Yeah, they're acute. They're between 0 and 90 degrees, or they're between 0 and pi over 2. Those are acute angles. So that terminology has not changed. It's now that we can refer to either degrees, though, or radians. Okay? And then between pi over 2 and pi. In other words, they end up here to here. Those are obtuse. Thank you. All right? Okay, so here we go. This is what I was doing on the previous page before. To find an angle that is coterminal. And what does that mean? They start and stop at the exact same spot. Okay? To find an angle that is coterminal to a given angle theta, add or subtract multiples. It's a T right there, guys. Can't see her. Multiples of 2 pi. And that 2 pi is 2 pi what? Radians. And every 2 pi radians is what? A full rotation. And I said earlier, every time you go around a full rotation, you have another what? Angle, and it's coterminal to the original one. Okay? That is how you can find coterminal angles. You add or subtract multiples of 2 pi. Okay, so before we go on, questions on this page? Any questions? So if you're walking down the hallway on Thursday, and Mr. Mitter or Mr. Gwendon, the 2 calc teachers, stop you and say, hey, have you learned about radians yet? You go, yeah, we just started it. And they said to you, explain what it is if an angle has a measure of 1 radian. What would you say to them? Are you prepared for that? Do you know what it means to have a measurement of 1 radian? It's what? When the arc length and the radius are the same. And then they look at you and they say, so how many radians in a full rotation? You better be able to say what? 2 pi radians. And if they say, well, what about a half rotation? You better be able to say pi rotations. And what if they said to you, hey, what's the measure of theta if its arc length is s and its radius is r? You're going to say what? What's that? S over r, arc length divided by radius. Those things we need you to know. You need to become very comfortable with this idea of radians, okay? Very comfortable with it. All right. Oh, there we go. So, to convert degrees to radians or radians to degrees. Okay, so let's think about this. Let's get a little conversion here. We know right now that 360 degrees is equal to how many radians? 2 pi radians. Okay, so we know that 360 degrees corresponds to 2 pi radians. I'm just going to put rad. Now, if that's true, we also know, because we said this earlier, that if I take half of this, 180 degrees would correspond to pi radians. Okay? Here we go. All right, so here we go. This is what we're going to do. To do this, I'm going to draw one picture of this, okay? So I'm going to put degrees here, and I'll put radians. Put radians over here. All right. If I want to convert from degrees to radians, so this one right here, I want to go from here to here. All right? I'm going to multiply by pi over 1
80. I'm going to multiply by pi radians over 180 degrees. That's the conversion factor. It's a conversion. Okay? If I want to convert from radians to degrees, the opposite direction, I would not multiply by that. I would multiply by the reciprocal. I would multiply by 180 over pi. Okay? That's what I would do. Okay. So if I gave you something and I asked you to convert it from degrees to radians or radians to degrees, you use this simple little thing here. If you're not told anything, if you're going this direction here, you leave it in terms of pi unless they want you to give an approximation. So kind of like if you were finding circumference, your teacher may have said, oh, the exact circumference means you leave it in terms of pi. So here we might do that. So if I gave you, I said the following, I said, hey, I want to convert, okay, let's just try one here. Let's say I want to convert, 100 degrees, and I want to convert it to radians. So if I'm going to do that, I'm going to multiply this by pi over 180. So it would be 100 times pi over 180, which is 100 pi over 180. But now I want to simplify that. I do want to simplify that. What's that? 5 pi over 9. Okay, now let's think about this. This is where we just want to get more comfortable with it. 100 is a little bit more than 90. And 90 is pi over 2. Is this more than pi over 2? Yes, it is. Is it a little bit more than pi over 2? Yes, it is. Because pi over 2 would be what? 5 pi over 10. I know by looking at it that sounds good. Because I know 90 is pi over 2. Okay? Great, there it is. So we could go ahead. So 100 degrees is 5 pi over 9 radians. Let's convert it. Right? Okay. All right. So now comes this bottom part. I cannot tell you how important this bottom part is going to be for you. I can't stress it enough. First of all, you'll notice it's called the unit circle. It is called the unit circle because it has a radius of 1 unit. It's called the unit circle, down here at the bottom, because it has a radius of 1. It's called the unit circle because it R equals 1. Okay? That's why it's called the unit circle. All right. Now, you'll notice on here, there's a lot of stuff going on. And you'll notice that there are a bunch of marks. These are known as familiar angles. These locations are going to be the familiar angles, okay? Now let me tell you what these are in degrees, what these familiar angles are in degrees. I'm going to write the degrees. Yeah, I'm not going to put those out here, because out here I'm going to put radians in a little bit. So right here, I'm going to put degrees. And I'm going to put these in green. We already know if I'm starting here, this is 0 degrees. We know that. That's the starting spot, right? Okay, guess what? Guess what this measurement is from here to here? It's 30 degrees. Guess what this next one is? It's 45 degrees. This next one is 60 degrees. This then, of course, is 90 degrees. Now, before I go any further, let's think about that. Those are the familiar angles. Those are also the angles off the special right
triangles that I told you you needed to understand. And this is why we're going to be using that special right triangle stuff here in a second. All right, so that's at 90 degrees. So what do you think this is going to be at then?
120.
Yeah, 120. Woo! This is going to be at 135. Love it. 150. And of course, we know what this is. This is at 180. Okay? Let's keep going. Let's keep going. What about that one there? 210. This one? 225. This one? 240. We better know what that's at. 270. 300. 315. 330. And of course, when I get back to where I started, I'm at what? 360. Okay? Those are in degrees. All right. So those are the familiar angles. Those are from special right triangles. Now let's fill in the radians real quick. While we've been talking about radians, let's fill this in. Okay. So we already said that 0 is 0 no matter what unit you're in. $0 is 0 yen, right? 0 inches is 0 meters. It doesn't matter if it's 0, it is 0. So 0 degrees, of course, is going to coincide with 0 radians. That's going to be this outside where those dashes are, that's where I'm going to put radian measurements at, okay? We already know some of these. Okay, here we go. Are you ready? Who knows what this one is already in radians? Pi over 2. And we know what this one is already. It is at pi. What about this one? What about down here? How many pi over 2s is that? 1 pi over 2, 2 pi over 2s. So it's 3 pi over 2. And then, of course, when we get back where I started, we know a full rotation in radians is 2 pi radians. All righty. Here we go. Now, a couple ways we can do this. We're going to do this an easy way. I don't want to use conversions every time. I don't need to do that. Tell me, how does 30 degrees compare to 90 degrees? It's 1/3. That means that this radian is 1/3 of that radian. So what's 1/3 of pi over 2? Pi over 6. Does that make sense what I just did? How I did that one? You could do the conversion if you wanted to do 30 times pi over 180. 30 over 180 is 1 over 6. It'll work the same way, okay? All right, 45 compares to 90. It's what? 1/2 of it. So what's 1/2 of pi over 2? Pi over 4. This one's a little harder, so we're not going to use the 90. But what is 60 compared to 30? Twice it. So it's going to be twice this. 2 pi over 6 is what, though? Okay. Now here's what I want you to do. I'd like to see if you can fill out these three right here now in quadrant number 2. And then we'll go over them. So would you please fill out these three in quadrant 2 in radians? In radians real quick.
got them? Maybe? Quadrant 2? All right, so guess what? Here we go. 120 is how many 60s? So how many pi over 3s do I need? 2, so it's 2 pi over 3. Okay. 135 is how many 45s? 3. So I need 3 pi over 4s. Oh, 3 pi over 4. 150 is how many 30s? 5. So I need 5 pi over 6s. Oh, 5 pi over 6. And we all know that's pi. Okay? We okay so far? We're doing okay? You with me or not? Chris, are you okay? Great, here we go. Let's keep going then. What is this going to be right here? Somebody just tell me. 7 pi over 6. Okay? Love it. Love it, love it, love it. Now, real quick, notice all of my things here were improper. Not improper. All of my things here were proper. That means the numerator was smaller than the denominator, right? We've got 1, 1, 1, 1, 2, 3, 5. Then we get a 1 is the coefficient. So now I know my numerator number better be smaller than my, better be what? Bigger than my denominator every time down here. It's going to happen. All right, great. What about right here? Where am I at now? Thank you. It's 5 pi over 4. All right? We're always simplifying these. This guy right here. 4 pi over 3. Love it. 3 pi over 2. Boop. Where are we at now? It's 5 pi over 3. This is 5 pi over 3, guys. This is at 7 pi over 4. This is at 11 pi over 6. So guess what? One of the things you're going to be doing is you're going to be memorizing those radians and where they're at. Because on Friday, I'm going to be giving you a blank circle like this, and you're going to have to fill it in. And it's going to be a timed quiz. All right? It's going to be a timed quiz. You will not be required to give me the degrees, because I'm not going to be using degrees hardly at all in here anymore. I use them today to help you become comfortable with radians. Our goal, though, is to kind of stop talking about degrees and only go with radians. So you're going to be required to be able to fill in these locations on these familiar angles in radians on Friday. Now, on Friday, you're also going to be required to fill in the ordered pairs. And you're probably thinking, what? Well, yes, you are. Now, we're going to fill in a few of them right now, the easy ones. Everyone in here should be able to tell me this ordered pair right here. And you're probably thinking, wait, whoa, I don't have enough information. And you do have enough information. What is that ordered pair at 0 radians, or 2 pi radians? What is that location at right there? What's the ordered pair?
1, 0.
1, 0. How'd you know it was 1, 0?
Because it's 1 unit radius.
It's the unit circle. It's a radius of 1. So this is the coordinate 1, 0. Now, if I know that one, I know 3 more real quick. I know this one up here is what?
0, 1.
0, 1. I know this is at -1, 0. And I know this one down here is at 0, -1. Those are gimmies. All right, are you ready?
I'm going to help you fill in this one right here. And then guess what your assignment's going to be? To fill in the rest of them. All right? Now here's how we're going to do this. Watch. I need purple. What's this length here? 1. What kind of a triangle do I have? It is a 30, 60, 90. It's a special right triangle. Okay, here we go. I have given you the what of the special right triangle? The hypotenuse. If I give you the hypotenuse of a 30, 60, 90, what's the easy leg to find? The short leg, which is this one. And it's going to be what? So this is 1/2. That means this y value is 1/2. Because that's the y value. Okay? So this is why we had to do those 30, 60, 90 rules and 45, 45, 90 rules. Okay? Once you know the short leg, how did you get the long leg? Times something. Multiplied it by a radical 3. This is 1/2 times radical 3, which is radical 3 over 2. Boom. All right. I've given you that. You're going to fill in the rest of these. And here's I'm going to tell you right now. The only time you have to use special right triangles on this, you have to do it one more time. And that is it. For this one. And as soon as you get that one, you don't have to use the special right triangles anymore. You have to use your brain and the idea of what is going on in the quadrants with the x and y values. All I'm going to say. When we come back on Thursday, you should have this filled out, and you should be able to kind of maybe tell me, hey, here's what I did to find from here all the way around. Because this one here, you're going to use special right triangles for. I'm going to tell you right now, this one, you're going to have to use special right triangles for. It's the only other one you have to do it for. All the other ones, you can just do it some other way. And I'm going to ask you, what is that? Okay? All right, that's it. That's all I'm going to say. I'm done. Tomorrow, watch online. I haven't decided yet. I might put something on there. I may not. Okay? But you need to have this filled out for sure for Thursday. All righty? Thursday. Yeah, there'll probably be an assignment tomorrow. It might be just a basic one on understanding radians. Oh, great.